Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled, The Accretion Theory of Planetary Formation is Impossible. Now, the accepted theory on planetary formation is that pieces of dust and small rocks come together in a process called accretion. The accreting mass eventually gets large enough to be a planet. But if you have two solid pieces of rock, no matter the size, as even pieces of dust or still colliding pieces of rock, just smaller, you do not expect them to stick together because rock is not a deformable material unless it is hot enough to melt, such as the magma ejected by the cores of the Earth and the Sun. And you may look at Article 522 entitled Stellar Cores or Sources of Matter or White Holes for more details. So you expect pieces of rock, no matter the size, to collide elastically and thus fly apart again or shatter into smaller pieces as a result of the impact. Because the attractive gravitational force between the two pieces of rock is simply too weak to compensate for the impulsive force of such an impact, which shows that the accretion theory is incorrect and illogical. In order to see that, let us suppose we have two pieces of rock about 10 centimeters or 25 inches in size, each with a mass of 1 kilogram, that's about 2.2 pounds, and moving at 1 meter per second or 3.3 feet per second toward each other. This is an extremely slow speed. Pieces of rock in a cloud of debris are most likely moving much faster than this with respect to each other, possibly 100 to 1,000 times faster. But even at this speed, and this is illustrated here, this relative speed of 1 meter per second, as we can see, okay, so these are about 10 centimeters in extent, mass is 1 kilogram, and they collide. And when they collide, there are impulsive forces that repel them, so tend to cause them to fly apart, and there will be the attractive gravitational force as well. Now let's suppose that the collision time interval is 0.1 seconds. In other words, the collision takes 0.1 seconds to occur. Then it may even take much less time than that, 0.1 seconds. And 1 second is quite a long time when it comes to a collision. So let's leave it at 0.1 second. Then the impulsive force is the change in momentum, which is 2 times mv for an elastic collision, divided by the time interval, 0.1 second. So we get a force of 20 newtons. This is the force that will drive the two pieces of rock apart after the collision. Now, the force exerted by gravity on the two pieces of rock at the point of closest approach is given by this equation. Standard Newton's universal law of gravitation. The two rocks have the same mass, gm squared, so it's m squared over r squared. So that's the gravitational constant given by 6.67 times 10 to the minus 11, which tells us that the gravitational force is extremely weak because this is a very small number. And then the mass is squared, 1 kilogram squared divided by 10 centimeters, which is 0.1 meters, and we get a force of 6.67 times 10 to the minus newtons. If you compare these two forces, you can immediately see that it is impossible for these two pieces of rock to stick together. The gravitational force is extremely weak. We have 9 decimal points after the point. You have 9 zeros after the decimal point. So this is 20 newtons and 6.67 times 10 to the minus 9 newtons. So we can see that the impulse force, which will tend to drive the two pieces of rock apart, is actually 3 times 10 to the 9 or 3 billion times stronger. And this is with rocks moving at extremely low speeds with respect to each other, which makes the impossibility of the accretion theory quite obvious. But some people may still wonder what happens with smaller pieces of rock. So let us suppose the pieces of rock now have a mass of 0.001 kilogram, that's 1 gram, and are 0.01 centimeters apart, 0.025 inches in size. We will leave the approach velocity the same, as well as the collision time interval. But remember that this is an extremely low speed, especially for small pieces of rock, which will tend to gain momentum and thus velocity when colliding with pieces of rock that are a bit larger. The impulsive force now is the mass times the velocity. Remember, if we had a larger velocity, this will immediately increase the size of this force. Divided by 0.1 seconds, and we get 0.02 newtons. The gravitational force stays the same. It's still extremely weak in comparison. So the attractive gravitational force has not changed, whilst the impulsive force has. But even then, the impulsive force is 3 million times stronger than the gravitational force, which shows that it is impossible for even tiny pieces of rock to come together to form planets. In addition, the gravitational force is so weak that the attractive gravitational force on, say, a 0.001 kilogram rock, 1 gram, piece in a collision with a 100 kilogram piece of rock, which now we will give it a 10 meter radius, placing the two centers of mass about 5 meters, that would place the two centers of mass 5 meters apart. So that's the distance we have to use in the gravitational attraction equation. So we work that out. We get now 2.67 times 10 to the minus 13 newtons. The gravitational force is now weaker by 4 orders of magnitude, basically. The gravitational force drops in strength when a small piece collides with a larger piece, clearly showing once again that not only is the accretion theory impossible, it is completely illogical. So in conclusion, the theory of planetary formation due to accretion is impossible and illogical. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.